In this video, we're going to be looking at the discriminant and what the discriminant is and how it helps us in determining our solution, which we will eventually do in a second video using the quadratic formula. All right, so first things first, all right, the discriminant is something that determines the type of solution. So we use the discriminant to determine whether or not our solutions are real or imaginary, but we also use them to figure out how many we will have. All right, so there's three instances. All right, you could have a discriminant that is greater than 0. And if that's the case, then notice on this picture that your graph would touch the x-axis in two places. All right, you can have a discriminant that's exactly 0 and it only touches your x-axis in one place, or you can have a discriminant that is less than 0, which would mean it would be negative, and then it would not cross your x-axis anywhere. All right, so in this first picture, you would have two real solutions and no imaginary. In the second picture, you would have one real solution and no imaginary. And in the last picture, you have 0 real solutions, but you would have 2 imaginary solutions. All right. So when I say solutions, you'll notice on the picture it calls them roots. All right. Well, there's something you need to know, that there are several terms that essentially mean the same thing. You have solutions, roots, zeros, and x-intercepts. These all represent where the graph crosses the x-axis, essentially where the y would be 0. All right, so right here, this is the equation. The whole thing is the equation for the quadratic formula. The discriminant is a small portion of that formula. So when we look at the quadratic formula together, notice the discriminant is going to come up, and we use it to kind of make predictions about our solutions. So again, the discriminant, the whole purpose of a discriminant is literally to tell you the type of solutions you'll have and how many. Okay, that's literally, okay, so you can kind of use this chart in the middle to kind of help you with that. You can also use this picture kind of as a guide of, really what does that mean in terms of a function and its graph. All right, so that is the discriminant. So some examples of a discriminant and how to find the discriminant is, number one, make sure that you're in standard form, ax squared plus bx plus c. And then you're going to identify your a, your b, and your c. Remember, the a, b, and c are the coefficients, the numbers, not the variables, just the numerical part. All right, and then you'll substitute into the discriminant formula, which is b squared minus 4ac, and then you'll use that to determine the number and type of solutions that you have. All right, so for this first example, our a value is 2, b is -8, and c is -14. So we're going to use those numbers and substitute them into our formula. Now, notice that b is negative. It's important that when you're squaring that you use parentheses, okay, especially when they're negative. And then minus 4, that's part of the formula. A is 2, and C is -14. So you can type that into your calculator all at one time. So I'm going to put parentheses -8, square it, make sure the square is on the outside of the parentheses, minus 4, that's not -4, it has to be subtract 4. A is 2, C is -14. And I got 176. All right, so my discriminant is 176. So what does that tell me about the type of solutions that I have? Well, if we look back at our chart, if the discriminant is greater than 0, positive, it's going to have 2 real solutions and 0 imaginary solutions. So this tells me, because it's positive, it's greater than 0, that I'm going to have 2 real solutions. All right, and you could put 0 imaginary as well if you wanted to. All right, so for the second one, A is 3, B is -15, and C is +12. So we substitute into our formula. Again, parentheses are super helpful. So -15 squared minus 4, A is 3, and C is 12. So again, we put that in our calculator. So I would have negative 15 in parentheses, squared on the outside, minus 4, parentheses with a 3, parentheses with a 12. And I get 81. So again, discriminant is positive, so I would have 2 real solutions. All right. Now this last one, A is 8, B is negative 24, and C is positive 18. So B squared would be negative 24 squared minus 4. A is 8, C is 18. All right, so we're going to substitute or put that into our calculator rather to calculate it. So negative 24, and B is not always negative. It just so happened in these examples that it was. All right, but minus 4, A is 8, and then C is 18. And I got 0. All right. Now, 0 is my discriminant. All right. Now, a common mistake is somebody gets a discriminant of 0 and automatically they think that they don't have any solutions, right? Okay, but that's not the case. Okay, so if the discriminant is 0, that means you have one real solution. All right. So let's kind of talk about this. I think this next slide is, yeah. All right. So I'm going to insert a slide real fast. All right, so if you had, think about what the discriminant means, okay? Because we're going to use the quadratic formula in the next video. But if I had something like 2 plus or minus the square root of 0 over 2, if that was my, the answer that I'm going to get with quadratic formula. Well, what is the 0? 0, right? So if I separated this and I had like the plus or the minus, all right, if I did 2 plus 0 over 2 and then 2 minus 0 over 2, then I'm going to get 2 over 2, which is 1. Well, that's the same answer twice, right? So that's why if the discriminant is 0, we only have one real solution because legit, we get one answer. All right, now let's switch that up a little bit. And let's say, what if I had 2 plus or minus the square root of 4 over 2? All right, well, I would have 2 plus 2 over 2, and I'd have 2 minus 2 over 2. All right, so right now, if the 4 was my discriminant, based on what we've learned, we should get two different answers, and they should be real numbers, correct? Well, we have 4 over 2, which is 2. And we have 0 over 2, which is 0. And again, that's two answers, right? That's two real solutions. All right, so that's why if you had a 0 under the radical, well then, something plus 0 or something minus 0, it doesn't change the answer. So that's one real solution. All right, so what would happen then if this was a negative? All right, so let's try that. All right, so if I had 2 plus or minus the square root of a negative 4 over 2, well, then I would have, remember, negative 4 under a radical would be technically 2i, right? So I would have 2 plus 2i over 2, and I would have 2 minus 2i over 2. All right, so this would end up, if I simplified everything, I would really have 1 plus I, and I would have 1 minus I. All right, well, those are different solutions because this I is the square root of negative 1, right? So 1 plus something, 1 minus something is going to give you a different answer. So, but those are imaginary because they include i's. So that would be 0 real and 2 imaginary. All right, so that's why it is what that is.